Hello students, it's Mr. Beamer here giving you your content for the live lesson. Now, instead of teaching it live, what I decided to do was make a recording in case there were people who wouldn't have access or had problems with Teams, which means I can email a link out to this video on YouTube, which anybody can watch and therefore do the work either on the day or later on. So, we're talking about exploded diagrams. Exploded diagrams. We're going to look at what it is and where they're used. So this is an example of an exploded diagram. So what you can see is that the product has been effectively taken apart, but it's not just randomly taken apart and all the bits, so just the components is the proper term, the parts, the components, they're not just randomly stuck all over the page. They're actually in line. They're actually in line so you can actually see how they fit together. Okay, now I've actually got an example of this very interestingly. So I was looking for spare parts for my motorbike and I went onto the Kawasaki site, and of course what do we see here? We see the entire sort of a frame assembly. So there's the frame of the motorbike, that's where the fuel tank would sit, that's where your front wheel would be, where I'm kind of moving the mouse. And as you can see, every single one of these has got a number, a corresponding number with a corresponding component, and I can then order whichever part I need. So this exploded diagram, it's not just random. You can see that this all fits down onto there, this fits in there, that goes into that spot over there, those go down into there. Do you see what I'm saying? So exploded diagrams are incredibly useful to us, okay? So what is it? It's when you take a product that's made up of a variety of components and then you separate all the components out in a 3D drawing, but they're all in line. All right. Okay, so why we use it, when do we use them? So there's a common example from IKEA. So this is from a bookshelf I bought several years ago, and obviously IKEA is all over the world, so they need to have pictures clearly explaining how everything lines up and how it connects. So the most obvious reason is it's international. Have you ever heard the phrase, a picture speaks 1,000 words? Well, does everyone speak the same language? The answer is no, but they can all understand pictures. And if we go back there, Roman numerals, as in 1, 2, 3, 4, 5, 6, 7, the way we write our numerals is common worldwide. So you may speak anything from Farsi to Afrikaans to Japanese to Portuguese, you name it, but you will be able to look at these pictures and look at the numbers and work it out yourself. Okay. Now here is an example. Look how many countries sell this drill. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I count 15. So that's 15 different countries where this drill is sold. So imagine if you had to do the entire instruction manual, everything in 15 languages. I mean, you'd have a fat book. Whereas here they've got pictures, clever use of arrows as well, of course, but also exploded diagram. So you can see here we see an exploded diagram of how the chuck fits the drill bit holder, and there's the drill bit. Exploded diagram. A picture speaks 1,000 words, as they say. Now we're going to look at how exploded diagrams are helpful to users, manufacturers, and designers and clients. So first of all, users. Quite simply, assembling products at home. Why is flat pack furniture less expensive? Because you put it together, you assemble it yourself. So instructions to people assembling flat pack furniture or other products requiring assembly or repair, because it's in picture, it is in pictures, it is truly international. So it allows you to actually buy less expensive products and put them together at home, no matter what language you speak. Now, a user could also order spare parts for a repair job the way I had to for my motorbike. So a user repairing his laptop might use an exploded diagram to see a part number which he has to order in order to carry out the repair. A user could also repair a product by knowing how to take it apart, disassemble is the proper term, and reassemble. So a user repairing her lawnmower might use an exploded diagram to see how to disassemble and reassemble it for maintenance, meaning just taking care of it, or to repair a broken part. And of course we've got children with toys. Now here we see a child playing with Lego. People who cannot read at all can use products because of clear instructions using, you got it, exploded diagrams. Now what about manufacturers? Well, manufacturers where stuff is made in factories. Here we see an assembly line for some kind of car. It looks like a bit of a sports car to me. Now, workers assembling products would use exploded diagrams as a visual aid to speed up training and help their understanding and minimize mistakes. So if you were training somebody like this guy over here to put together this brake and wheel assembly, you would show them an exploded diagram so they could see all of the parts, the components, and see how it goes together. You'd train them more easily. They could check up on their own work more easily because they don't have to just remember it all. It's very clear. And of course, you'd have fewer mistakes. Now, workers in a construction or JIT, just-in-time production line, would know which parts from their workstation need reordering so that production does not stop. Now, just-in-time production literally means you don't make it in advance, you make it to order, which means you need to have all of your spare parts. So, for example, do you see that little bolt over there? See that bolt where I'm moving my mouse? If this bloke, ran out of those bolts at his workstation, could he put together his wheel assembly? The simple answer is, of course, no. So he would have a part number for that bolt. Okay, I know this drawing doesn't have part numbers, but you saw the motorcycle example I gave you. So he could also make sure that his workstation doesn't run out of bolts. Let's say that bolt was called I don't know, I'll make something up. E13 bolt. So at this factory, this bolt was called an E13 bolt. Incidentally, all of those bolts would probably be E13s because we call that a standard component. So it's easier for all the bolts to be the same size. So he would look on the side of his workstation, he'd say, oops, I'm running low on E13 bolts. He would send a message to the people in charge of logistics for the factory and say, excuse me people, can I have some more bolts because I'm running out, and they'll send some more down the assembly line so he can continue doing his job. Now what if you worked in a shop, for example you were a bicycle mechanic and you had to know how to repair parts like that brake on a bicycle. It's actually a gear shifter brake. It's very, very, very complex. Or this derailleur, which is the proper word for that thing at the back of your bike that changes the gears. Look how complex it is. Now this would enable that person who is repairing the bikes to be able to easily identify, first of all, how to take apart and repair a broken component. Remember, component is the proper word for part. And they could also see the part number so they could order spares if a customer needed it. So mechanics would read instructions that use exploded diagrams to make sense of assembling and disassembling complex components. And of course, designers and clients. Well, designers might use exploded diagrams to explain concepts or products to client. Every detail could be shown clearly and would also be very engaging and interesting to look at, so the client wouldn't get bored, as we can see from this concept drawing for the Batmobile. You could also use it as a way of promoting the product and advertising. It makes it clear to users or clients what the inside working technologies are. Now, we're going to look at some examples, and this is something which is a bit of an extension. It's very cool. I like it. I think it's great. It's about 8 minutes long. It's a very good example of creating a very, very good quality exploded diagram, and I mean very good quality. So the link is down there, and I know this is a video, not a PowerPoint, but if you type in on YouTube, Design Sketching Tutorial Exploded Views, and the channel is called Shaping Elements, one word. Very, very good. Very good. Okay, I'm not going to show it now. Now here are some examples of exploded diagrams. We take this box, we imagine how we separate all of those parts, and there we see. So part A has been moved off to the left, part E has been moved off kind of to the bottom right. Now I did these drawings deliberately quite loose and relaxed because I wasn't focusing on super accuracy. I was focusing on just getting the point across. So you can see how there is the original box, and we want to explode it, meaning separate out the parts. And in this case I've separated out, exploded parts A and E, which allows us to see inside. Now this is the full exploded version, so here we have A, B, C, D and E all separated out so you can really see it very clearly, and all of those pencil lines are basically just where I've lined everything up. But you don't need to draw something like this straight away, it's more challenging. Now, why would we use it? Well, here's an example from somebody's coursework, from their non-examined assessment, their NEA project a couple of years ago. So this is an example of a little stand type thing. I forget what it was even meant to hold, to be honest. But basically it shows how the whole thing would be assembled and the different components. Component A and A are the same, as you can see. Then there's component B, then there's component C. Then you can see there's a dowel over there. And there's annotation all over for the person to explain how it might be joined. So people who are in their GCSE or A-level projects who are getting close to showing how your product would be made, you would do very well to study this particular screen. Maybe pause, have a look at it. Okay? Actually, I come to think of it, I just remember, this isn't student work, this is work that I did a couple of years ago as a demonstration of what would look very good if it was student work. So yeah, if you're at that stage in your project, in A-level or GCSE, definitely worth stopping to look at this. Here are some real examples from student work. This is from a couple of years back. So here we see an excellent sketch of an exploded diagram of some kind of light. You can see here's the base, and there's the light, and there's the top. And then I think this is where the light fitting went. So this is kind of the base for a light, a lamp. This is excellent. This was a student's actual product that they designed. And you can see parts, component A, B, C, D, E, how it's all joined. And this was used as to explain how their product would be manufactured, which is an extremely important part of a designer's job in the designing section for Year 11 and Year 12 and 13 for your coursework. Now, this is how it was used, because do you notice it says here, complete template for pieces B, C. Talks about B, C. Pieces D, E. Pieces A, B, C, D, E. How do we know what A, B, C, D, E means? Simple. It's been mentioned over there. So that only really makes sense for how you would make your product as part of your planning if you've also got the diagram so you know which components are which. Okay. Here we see a beautiful exploded diagram created using CAD. Similar principle. Everything's labeled, and he can then use it to explain how the product is put together. And this is an animated exploded diagram created using CAD, which is extremely high-level work. So you can very clearly see how the product is put together. So this is very, very high-level, impressive work. This student was quite amazing. Also got top marks, of course. Okay, and then they had the labeled parts. Now here's that's what I'm looking for. This was a student's final idea, final proposed prototype. There she checked it against the spec, and there produced an exploded diagram with all the different components. There was a cutting list, and you saw how it fitted together. So that's why it's used. So what have we learned about exploded diagrams? Where are they used? Just give it a quick thought. Think of the users, think of the people in factories, and think of designers. Sorry, I'm going to pause to let you do that. Think of designers and clients. Okay, now think of a very popular shop that sells furniture that uses exploded diagrams to help customers put together, assemble their products they've taken home, they've bought. Okay. When might you use this technique? Well, we've just seen that. So that is a piece of Year 11 coursework and NEA, as we call it, non-examined assessment, and it is a beautiful example of that final prototype being presented as an exploded diagram to clearly show how it would be put together and made. Okay. So we looked at all of these: mechanics and workers, users of products like the little girl putting together the Lego, designers and clients, as well as factory workers and factory owners. Now, here's what you're going to do. I'm going to skip ahead. Your task for this lesson, and to bring this sketch to your next lesson when you see me, is to find a product from home which has several components, parts, sketch an exploded diagram showing how all of the components fit together, and label the components, and please bring the sketch to your next lesson. So if I go up, you will find, for example, this. This is a very good example, although I didn't ask them to label the parts. But this is very challenging. If you feel confident, yeah, go for it, but it does not need to be this complex. Okay, it might even be a toothpaste tube with the lid being in line showing how the lid would fit on. It might be an electronic product. Let me just go back to the task. It might be an electronic product showing how the back comes off and the batteries come out. It could be a torch which you've opened out and shown where the batteries kind of fit in and how it closes together. It might be a travel mug that's got a lid that comes off, so you're showing the two objects in line with each other, but not together, but separate in that exploded style. Yeah? Now, as part of this lesson, what I'm going to do is I'm going to send you a link to this video, which I put together, and this is how I created an exploded diagram of this little mini project I did a couple of years ago for a little homemade sweet dispenser. Kind of a fun project where you just put Smarties or something in the top, and then there's a little wooden thing on the bottom that you kind of twist round and it pops out a sweet. It's just something for fun. So I will email you this link, or I will put it into the chat on the lesson, and then you watch that video. It's only 5 minutes long, and then you do this task and bring it to your next lesson. Okay. Thank you very much, and I look forward to seeing your lovely, lovely work.